and now we're going to get into kind of the now what of it. So that's kind of, I don't mean to paint a bleak picture about application whitelisting. Every solution you're going to implement is going to have some vulnerabilities around it. What's important is that you educate yourself on what those vulnerabilities are. One, so that you know what to look for, and two, so that you can actually take some steps to mitigate it. So with any security technology you implement, I think the first step is simply to educate yourself on it. So if you're looking at a vendor, go out and educate yourself on that topic. And I think the absolute best starting point for this is simply to ask the vendor themselves about what vulnerabilities exist in their products. Because if anyone knows what exists, it should be them, and if they don't, you have a bigger problem on your hands. So that's the first thing I'd say is go talk to a vendor, try to have an honest discussion. And from my position in the industry, I don't get that question enough when I go and talk to people, and that's a question I really like to see asked, because when someone asks me, how do I defeat your product, what are the vulnerabilities, what do I need to watch out for, I can have a more meaningful security dialogue with them, and I'm able to better see if our products are a fit for their environment and what additional steps they might need to make it most effective. So I think the first question you need to ask is what inherent vulnerabilities exist in the approach a security product has. And by that I mean no security product that is designed to do everything does anything well. All the best security products are designed to do one thing or a few things really effectively and efficiently. So you have to identify what that product isn't designed to do so you know what it won't do. So look at signature-based antivirus. Its design is to detect something it knows is bad and prevent it from running. And at that, it does a good job. The problem is people expect it to do something it's not designed for, like detect unknown malware. So if you're expecting it to do that or relying on it to provide that functionality, you've created a vulnerability in your environment. Similarly, application whitelisting. It's not designed inherently to prevent a whitelisted application from being exploited and having malicious code run on it. So if you're relying on it to do that, you've created a vulnerability. So that's kind of the first step. Ask what inherent vulnerabilities exist in it so you can understand where you still need coverage or what you need to do to mitigate those. Then another thing you need to consider is what sort of vulnerabilities are exposed from the ease of use features you enable. And by that I mean security products often give you ways to make it easier to manage a product or to minimize the impact on an end user. The problem is most of these sort of ease of use things also create new security holes. So to the question that was asked earlier, why are you going to trust a certificate from Adobe or Microsoft if you have reason to believe that it might be spoofed or illegitimate or somehow otherwise tricked? And that reliance becomes a new vulnerability you have to keep in mind when you're implementing a product. And to that point, I'll go on a little rant here, and that's public key cryptography is a great technology and a lot of really important functionalities built on top of it. And when it's used for what it's designed for and how it's designed to work, it works really well. Unfortunately, I think in the security industry, people have taken it and tried to apply it to an environment it really wasn't designed to work in. What public key cryptography wants to do is take a trusted source A and a trusted source B and ensure that this untrusted link between them isn't able to interfere in some way with data that's being sent between the two, which works pretty well until you no longer trust your source A. So say, for instance, in the case of Stuxnet, when they infiltrate J-Micron in order to get their legitimate certificate to sign their own malicious code, now all of a sudden, if you're relying on this trusted source A to say that software is good, it's telling you Stuxnet is a good piece of software you should allow to run in your environment. And that's obviously a vulnerability. And I think it's a particularly large vulnerability because the hardest organizations to secure are actually the software development houses, because they're constantly churning out new code, so you can't rely on techniques like application whitelisting. Behavioral solutions typically have a lot of trouble with them as well because they're usually implementing more sophisticated technology and techniques just from the coding. And then also you have a bunch of administrators running in an environment with high level access And that in and of itself becomes a vulnerability. And then even to take it one step further, the people who are developing particularly effective malware tend to be pretty good coders. So if they really want to, all they need to do is get a job with an organization they like the certificate of, infiltrate it from the inside, and now they have control. So that's one problem with trusting these certificates entirely as part of a security solution. The other part of the problem is if you don't trust your point B. And as I demonstrated with our demo, I can change the way a computer views its certificates. So something that you think it should be accepting, I can change it to point to my fake cert store. Or if I wanted to, I could use that kernel level driver to tell you that a executable that isn't signed by a legitimate thing was actually signed by Microsoft, just by changing the bits that are read in by it. So the problem with this sort of reliance on certificates is that you have a technology that is being sort of misapplied. And it's not a problem if you're not explicitly relying on it, but if in order to use a security technology, you need that to be something you trust, then you're going to open yourself to a whole host of vulnerabilities you wouldn't have if you had gone with something that didn't suffer from that. So that's kind of one of the takeaways is don't rely explicitly on certificates to provide security. Use them as an additional way of establishing whether something's trusted, but don't just close your eyes and trust everything that happens to be signed or looks like it's signed. And then finally, you need to ask how a product from a security vendor can be attacked directly. So if you look at a lot of the malware being developed today, it's designed to directly attack the security products it knows about. And that becomes a real hole. And if anyone should know how their product can be attacked, it's the person who's actually building it. So I think the important thing is you ask these questions, because without that education, you don't have the information you need to actually provide an adequate security model around your organization. And the reality is the first person you're going to talk to at a specific vendor probably isn't going to have the answers to these questions. So you should really be burrowing down and be insistent about talking to someone who can have that sort of honest, open dialogue with you about these vulnerabilities. And if a security vendor isn't really willing to honestly discuss those vulnerabilities, and if you have to sign an NDA or whatever you have to do, jump through the hoops to do it. But if they're not even willing to talk to you about that, I'd say look elsewhere for your security, because how can you protect your organization when you don't know what you don't know? So that, I think, is kind of the first step at, what do we do about these vulnerabilities that exist in security products? And then I think the second step is don't stop there. I think the really easy tendency is for someone in the security field to get a shiny new toy or security tool, implement it, and think that they're done. And I think that's really tempting, and it makes a lot of sense until you realize that there's these vulnerabilities that are present. And what I'd say is, instead of stopping at the deployment of a security technology, take the time to look at those inherent vulnerabilities you learned about and see if there's anything you could do about it. So, for instance, in the demo, I demonstrated how there's an inherent vulnerability in an application whitelisting product that uses a kernel driver. If you slip yourself underneath, it can't do anything about it. So you have to ask yourself, do I have an existing tool that exists in my organization I can use to detect that sort of behavior? So if you have something that's capable of detecting a new driver being installed, put in the registry or in one of those system locations, well, now all of a sudden you've managed to patch up a hole that they had in their product and you're safer for it. If you don't have an existing tool, then the question becomes, is this vulnerability large enough for your organization that you're willing to either buy an existing tool to solve it or develop your own? So in the case of our company, we looked at the products that are out there and we said, obviously, we don't like what they're doing, we're going to do our own thing. Now, I don't expect most organizations to go off and write sophisticated security software to solve those sorts of problems, but I think there's some areas where they can actually do little things that make a big difference. So I think the first thing is, that's a little bit easier to handle, is to ask yourself, how can a product, how are those ease of use features exposing me to more vulnerability? So if there's an ease of use feature you don't absolutely need to manage a security product effectively, turn it off. That's simple, it provides you with a greater level of security and you aren't exposing yourself to the same risk. And then I think the other area that's a lot easier to address is simply the direct attacks on a product. And I think that might be a little counterintuitive first until you think the way a malware developer thinks. So when a malware developer wants to attack a product directly, typically what he does is he goes out, he acquires a version of that product, either by downloading their demo, as I did in this particular instance, or torrenting it through something, and they install it on a computer. And they literally test things against it to see what works and what doesn't. And when it works, they use it, and when it doesn't, they don't. So before they've ever released a piece of malware, they know whether it's going to be successful against any given product. Now, what you can do is if you create additional checks and balances to ensure that that product isn't being attacked directly, you kind of wrestle that control back. Because a malware developer isn't going to have direct access to your environment unless you have either an insider situation or a highly targeted attack, which means they don't know what checks you've put in place. So while that technique may successfully disable a security product, if you see a security product disabled, you now have intelligence and know that you have malware present on that computer, or you have some kind of security malfunction which you'd want to know about anyway. So I just want to give a few examples of kind of simple things you can do to put that in place. The first is to simply create your own script that triggers a reporting event by that security product. So most organizations are kind of reliant on the reporting that comes back to them, but I don't think a lot of them go to the extent of testing on a regular basis whether that security product is working. So literally, if you have signature-based antivirus, put a known malicious file or a test file that is flagged as malicious and install it through whatever software deployment tools you have on each client in your environment. And then see if it gets quarantined and see if it reports. If you see that it hasn't been reported, you know that security product's not working. So either the product's malfunctioned, and that's important information because you want to address that, or some malware that's present on the computer has somehow subverted the reporting characteristics, or has changed the way it operates so that it no longer sees that file as malicious. And by taking that step, now you've addressed a flaw that that security product had in a way that malware developers aren't able to really detect. And then a second example would be to look at the yes.
Paranoid person that I am. The fact that you put a test file on there, even if it reports the test file, does not necessarily mean that you have the problem.
Correct. Yes, and there are additional steps you can sort of take around that as well. The intention is to put something in place, like take some sort of steps to ensure that the reporting is working as expected, because particularly sophisticated malware is going to change the mechanism by which those products report. So on your end, it's going to look like it's functioning just fine, and it's going to modify it in some way so that you don't see what's actually going on in that particular computer. But yeah, to your point, it might be doing it in sort of a more sophisticated way, only not reporting something that gets, one of its own malicious files or things of that variety. And that sort of method isn't going to be detected by this, but at the same time, you're dealing with a situation where you are no less safe for having implemented this, and as long as you're not making the assumption that it's foolproof in its entirety, if that makes sense. So, and then the second thing I would say is to monitor for, use a tool to monitor for the status of a process execution. So if you have a antivirus product on that computer, one of the common techniques is to disable it in some way. So it's going to shut down its process or things of that variety, and then maybe change the way it reports. Well, if you have your own agent on that computer watching to see if that process ever dies in an unexpected manner, and you're reporting it back through some other channel malware developers aren't aware of because they weren't able to, take it off the shelf and install it, now you have a way to detect that that sort of event occurred. And again, it might have been a crash of the antivirus product, but you probably want to know if it's crashing in a way that's unexpected. Or you have malware present on the computer that has shut it off, or a user who has, has admin rights who shut it off. And again, this is all important information you'd want to know, but it's something you're not going to get if you simply install a product and walk away at that point. So the basic advice I'm trying to give is just, if there are little things you can do to address the vulnerabilities you learn about when you're talking about, or when you educate yourself about a security technology, you can stop being that sort of low-hanging fruit that malware developers are after, and you're able to better secure your organization as a result of it.